Okay. So the claim is that the debt has decreased. So the claim is the mean is now less than what it was. So it still doesn't have an equal sign, so it's got to go here. And this guy's got to be the opposite. There's the beautiful thing about inequalities. As long as your variable is on the left side, the inequality symbol is an arrow, right? For algebra, it was an arrow in the direction to shade. Remember shading on the number line? For us, is the arrow pointing where the tail is. Tail's going to be down. Because where's the sample got to show up to show evidence that it's less than 906, below 906. So it's going to be a 1 tail down there. Beautiful picture. Not really. You can just say 1 tail. We already talked about this one also. N is 81 bigger than 30. Central limit theorem says normal enough, right? And sigma is unknown. We only know S. Therefore, we must use t-scores. Okay. Alpha was 0.01. It's a one-tailed test. What's the degrees of freedom? 80. So you should be able to look up to see what that t-score is going to be. Anybody got that? I think I gave away my last chart.
2.374.
2.374?
Negative.
Negative, good. Okay. Let me stop for a minute. Is everybody okay so far? You guys, I know this is really feels long, I know that, but do you see very many very familiar things, hopefully? I mean, everything we've done has gotten us ready for this, basically. This is a problem that has everything in it. Holy shit. How do I say that in words if T star is less than negative 2.374? What can we do?
Reject H null.
Let me say, I haven't really said this yet, but when I do this, I've listed one situation. I said the same thing twice. It's like me saying, I'm older than you, and then I say, you're younger than me. Whoa, what a revelation. I just said the same damn thing twice, right? So if I think this guy's wrong, that inherently means I think the other guy's right because they hold opposite viewpoints. You like it? So we either do this or I fail to do this. So we're going to find out which one. So what do we know from the sample? X bar was 880.34. Right. Standard deviation 106.25. N was 81. And this, of course, has to change. I need the one for groups of 81. And that, of course, is like 11 point something, maybe?
11.81.
11.81? 0? Oh, double check.
Yeah.
Yes? No?
Yeah. 1.
11.81? 1? What did you guys get? No? 806. 806? Maybe? Okay. I love you guys. So now I can do my T star, our data, minus the supposed middle, divided by the correct spread. And, whatever the hell that is, 2.4. Negative? I don't know. Is that right? No. What is it? You're not going to let me know. Fine. I'm out of here. 2 point. All right. Negative 2.17? Okay. Did we make it? No, we suck. We got right here. Is that still pretty far away? Is it? Negative 217. Is that still pretty far away? Yes. So in this particular instance, we did not reject the null. Does that mean the null, we're going to say it's the sin's right? No. Especially if I really believe in my claim, I'm like, well, let me take a bigger sample or another sample. Let me try this again. That's why we reject it or we fail to reject. Not yet. I ain't got you yet, null. Right? So I'm going to do it again. I don't accept it and stop. Right? I've been disproving it, so it must be right. No, that's bullshit. It's not how anything works in science. I've said this a few times to a few people, but I will never ask you for a p-value for a t-score because you would need a z-score size chart for every degree of freedom on the t-score chart to be able to answer that. If you don't quite understand why, okay, I'm just never going to ask you for a p-value for a t-score. You actually could give me a range, but that's all I'm going to say about that. All right. So we're just not going to get a p-value. Too bad. We'll be all right. Can you get a p-value? Hell yeah. A little calculator, spit it out. Little spreadsheet, little formula, spits out the p-value. Blah. So they'll report p-values from t-tests in articles and stuff. You already know my stance on that, right? All right. So what's our conclusion? What can I say right here? We fail to reject the null. Fail to support the high. So we have no idea. We have not found sufficient evidence to what? Good, because the claim was the high, so I'm going to use this language. We have not found sufficient evidence to support the claim that mean credit card debt has decreased since 2 years ago. Whoa. From 2 years ago, whatever the correct grammar is there. Just put it in the Grammarly. All right. Yes. Oh, yes. It's such an energizing thing to do. Sorry. It's confusing and it feels like a lot of work. I understand that. When I learned this, it was 8 steps. So, shut up. I made it 5 steps. It's a little bit better. All right. Last thing. This is it for today. Don't get too excited. What if I want to do a hypothesis test for a percentage? A few things have to change. I'm going to have the same 5 steps. I already promised you that. 5 steps won't change. The differences will be, instead of using the symbol mu, I'll use the symbol p. Ooh, it's amazing. Because now I won't be talking about a mean, I'll be talking about a percentage. So pretty cool so far. Nothing amazing. How do I check for an NPQ problem? This is going to be a percentage problem, right? How do I check to see if it's normal? So in step A, I'm going to use P, not mu. In step B, how do I test for normality for an NPQ problem? Come on now, it's not that long ago we did this. How do I test for normality with an NPQ problem? N times P and N times Q have to both be at least 5. So you have to look, N times P and N times Q have to be at least 5. Or don't put a check mark, we don't know. That's what you got to check. So instead of n greater than 30 for means, I have to use this check for percentages to make sure that it's normal enough. And then the next big thing that's going to change is the 4th step. I can't calculate z star with x bar minus the mu. I don't have any of that shit. I have n's and p's and q's. So let's see. Normally, or the 4th step was this before, right? Or an S down there. You guys with me? Yes? So do you see how the top is going to be our data minus the mean, which makes sense. How far is our sample away from where the supposed middle is? So for percentages, what symbol do we use for our sample percentage? P with a hat. And the book, just because I always forget this, the book uses this because the book is stupid. They use P prime. The book isn't stupid, I take that back. I picked it. But in some cases, the book is temporarily stupid. And we know that should be P hat. So the new Z star formula is going to have my data, P hat, minus the expected P. So we're going to have a claim like, I think it's more than 30%. So then P would be 0.3, and P hat will be what I get from my sample. So still our data minus whatever the accepted value is from the claim. And what's supposed to go on the bottom? The spread, the standard deviation. Okay, now I told you this was going to happen. What is the, oh shit. What is the, in fact, let me remind you about a couple things. Here are the three. I'm only writing this down for two reasons. All right. Those are for what? What are those for? Creating, yeah, you got plus and minus. Bam, bam, confidence intervals. So do not use these formulas. I'm not going to use these in a hypothesis test because nowhere in the test, any step does it say make a confidence interval. So please, dear God, don't use these formulas if I'm not asking for a confidence interval, because that's what these formulas do. Maybe. So two things I want to tell you about. I want to tell you this earlier, and I just forgot until now. What are you not allowed to have on formula sheets? Notes, or basically anything else besides what I tell you. But these are notes. When do I use a Z? When I know sigma. When do I use a T? When I know S. I can't not let you put that on the formula sheet, so you have notes if you use them as such. When do I use those things? Oh yeah, these formulas tell me. They do. This one, what did I tell you? What this piece of this must be what? Comparing it to the other ones. This piece must be, you can do it. What are these? What is this? What is that? The means. The sample, the standard deviation for the means. There it is, Josh. You do it. Standard deviation for, given that we've taken a sample, right? Therefore, this must be that same thing for the NPQ problem. So I told you when we did this, we're going to steal this later, and that later is now. So, what's supposed to go on the bottom of a z-score formula is the spread. Well, the spread for NPQ problems is this. Now here's the neat thing. I'm going to write it. Can you tell me what I've changed? Yeah, no hats allowed in this thing because what is P hat again? And what's P prime? P hat. Oh shit, we're just never going to escape. What does that represent? The percentage from a sample. And like, for example, what is oh Jeff, what are you talking about? I don't know. I only have to use this if I don't know P. Same way I would only use S if I didn't know sigma. I would only use X bar if I didn't know mu. Are you guys, is that cool? Maybe a little bit? In a hypothesis test, what do we assume to be true? Whatever the P is they give me. So I know P and Q. I don't have to use the hatted ones, which I still think is a good name for a band. Right? So I don't have to use the ones with hats because I'm going to assume I know the percentage. So let's do one example of this and then escape. So you're all like, did he forget to bring it? That would be so awesome. But no, I did. I brought it. Sorry. As I do this, I want to remind you that on tomorrow we do have a quiz. Maybe not reminding, actually telling most of you right now. We have a quiz tomorrow on chapter 8. What's happening Monday? Yeah, holiday Monday. Holiday on Monday. So what's happening tomorrow? We're going to do the quiz, we're going to finish up stuff, and then we're going to have a review for the test that's happening on Tuesday.
Is that even a holiday? Could you guys put on that?
Yeah. Yeah, next week is the last week. Wow.
Happy birthday, man. I know I'm a little late, I think, but early, but the timing
Huh?
is
Right, yeah, that's right. You guys do realize that, right? Next Friday is the final. Huh? Oh, yeah. And that's not just because I'm evil, because I am. It's because it's actually a college rule. So if you have a teacher that doesn't do that, they're like really cool.
Doesn't do what?
Give you a cumulative final. They actually suck, but it won't. All right, guys, let's do this one together, and then get out of here. All right, Chicago policeman. Finally, I gave you. We'll see if you guys pick up on this. What's happening? You guys all right? All right. Which sentence has information from the sample? Second one, it's got the word sample in it, it's a giveaway. So don't worry about that sentence at all for this first step, because the first step is all about how we feel about something before I even take a sample. So what's the claim that's being made? At most 55%. So what symbol should I use? P. And what's at most mean? You could be at most 12 to eat off the kids' menu at Denny's. So you have to be 12 or less. So at most 55 is less than or equal to. And what do I write there? Less than or equal to what? Thank you. Please get in the habit of immediately changing percentages into numbers. So we have to use numbers. It's crazy. All right, here's our first time. Holy shit. So where does that go? Yes, it's got to go on the hoe. Sure, what the hell? Well, it says it in. So that's definitely going to go for the null. Is that cool? Why? Has an equal sign in it, doesn't it? The null is always got to be the statement that believes it's somewhere around the middle. So that's why it's always having an equal. So why is it? Because that's the way we set it up, so that every test has the same rejection region kind of coming from the same place. So P less than or equal to 0.55 is here. So what's the high? P greater than 0.55. So how many tail test? Where? Yeah, greater than, so up here. So the H1 always sets up the rejection region. The other thing I wanted to say, how many confidence interval formulas do we know? 3. There's 2 for X bar, because you got S or Z, right? But there's only 1 for percentages, because either it's normal and use Z's, or it ain't normal and you don't do shit. So that's why I just say right here, is it normal enough? What do I got to check? You know. N times P, and N times Q. What's N? Good, 996, not the smaller number. And what's P? No work to do. We wrote it down. 0.55. So what's Q? Holy shit, right? Because they have to add to be 1. So those look like they're definitely going to be bigger than 5. You just write down what they are. 48, 49, 2, 47, 547. Right? What is it? Yeah. So this one's going to be 446.2? 8.2. Damn it. All right, I'll quit tomorrow. All right. I'm sorry. So that takes the place of n greater than 30. N greater than 30, essential limit theorem, it doesn't make sense unless it's talking about means. This is about percentages. I need to use the correct test for normality. I love that word. So it's normal enough, I can use z-scores. This step is the same as always. And this is a little bit less evil than before because you can actually find this one. Can you guys find the z-score? How many tail test? One tail. I can use z-scores because it's a p problem. Alpha is 0.005. What's it going to be? One tail, 0.005. Z-score. So you go to the which column? The first column. And you go all the way down. Yeah, so 2.576. Kick ass. What's up? Is that all right? So how do I say that in words? If Z star is greater than 2.576, what can we do? Reject the null. That's why it's called the rejection region. It's crazy. I think the book calls it the critical region because they're not stupid, they're just lame sometimes. It is the rejection region, which goes right along with rejecting the null. And which also means I support the high in that case. I give you all the steps for part D, so you guys do part D. I give you everything you need. Part D, there's that formula we came up with before. Oh. So what do I put down there for p hat? Good. At least 3 places. 596. And now you just fill in your z-score formula. No worries. Fundamentally, the z-score formula has always got that same idea. How far away did our sample get from what the middle was expected to be? So the next big challenge is to put this in the calculator correctly. I'm not saying this will never happen, but if you get a z-score of like 48 or something, that is most likely a calculator mistake. Z-score 48 would be insane. That is the 50-foot dude or something. How tall is he? 50 feet. Okay. Anybody got the z-score z-star value yet? 2.918. Hey, that's what I got. Of course, here I ask you for the p-value because these are z-scores. I can ask you for the p-value. So take a minute If you had trouble getting the 2.92, let me know. But look up the p-value for this. Thankfully, it's a one-tailed test. You did 596 minus whatever this is. Calculator understands order of operations. So I would divide before I would subtract. See, you have to tell it. You have to tell it, do the top first.
You gotta do 1 minus that square after that.
Oh, I see.
Now you do that. Alright, what do you guys get for the p-value? No. No. So if you look up 2.92, I get 9982, and of course to get the p-value, you gotta do 1 minus that, because I want the area in the tail this guy makes, so it'd be the area above this guy. So here's this guy. There that guy is. I'm trying to find that area there to be the p-value. So of course to get 0.00, you can do it, Jeff, 18.
You could just look on the opposite.
Exactly.
Z-score
If you know the shortcut, look at the negative z-score, you get the answer. I love it. Kick ass. Let me stop there for a minute. Is everybody okay with that? And again, I mean, obviously we have tomorrow to do even more of this shit, but you don't have to immediately today know this stuff. You don't want to do any more? You want me just to give you a test tomorrow instead? Is that what you're trying to say? Mister, you don't like anything? All right. So, yes.
I had a question about it.
Oh yeah, okay. So, did we make it? Did we make it? Yes, so it is greater than 2.576. Therefore, we can do those two things, right? Yes, yes. So we can do these things. Which one was our claim again? What was the claim? Which one? You can see exactly what the claim was. Where did we put it? Yeah, the null. What was the claim? Less than or equal to 0.55. Where did we put it? On the hoe, right? We put it in the null hypothesis. That's the claim. Do you guys see that? Does that make sense? I mean, that's it. Which one is our claim? Not H1. That wasn't our freaking claim. Our claim wasn't greater than. Our claim, we can see it right there. It was less than or equal. That's the hoe. So what language am I going to use? The language that relates to the null hypothesis. I'm going to use the reject language. So, did we reject the one that thinks it's in there? Did we show evidence that one's wrong? Yeah, that's all we're going to say right now. We found sufficient evidence to reject the claim that it's at most 55%, because we got to wait that shit up there. It ain't over here, it's over there. So we have found sufficient evidence to reject the claim that at most 55%, and I'm tired, so whatever, you plagiarize. At most 55% of Chicagoans. Isn't that how you say it? Who's from Chicago? Anybody? Nobody? So I can say however I want to. All right. I'm pretty sure it's not Chicagoites or something. Something else I was going to say and I forgot. Oh, sorry. Okay. So that's plenty for today. I'm